actually, interestingly enough, all about rising sea levels. So, I'm going to play some music, and in your groups of three, yeah, Allison. In your groups of three, I want you to dance appropriately to the music I'm about to play. Are you guys ready? Yeah, be linked up when you dance. She's videotaping us. Oh no!
If they get on YouTube, I can see it coming.
Dance to the music. You got it?
Yes.
No, not that. No, you don't want that. No, we don't have to stay in the same place. Dance like nothing wrong. I know. Look at that. We have our arms singing everything. Not working out. Yeah.
Very beautiful. Very beautiful. Okay. All right. Excellent. Now stay where you are. I'm going to play another song, and I want you guys to dance appropriately to the next set of music. Are you guys ready?
Yeah.
Difference in your dancing? Different energy. It was livelier the second time. Okay.
How much? Took up more space.
Took up more space the second time?
Second time.
Okay.
We were banging into each other.
Banging into each other a little bit more. All right. Took up a little bit more room. We're a little bit more energetic. So the groups of three that you were in were carbon dioxide or water. So if you're in the ocean and you're water, you're H2O, and it's nice and cool and quiet and calm, you kind of move around slowly and you don't take up too much room. But if it's warm and excited and energetic, you're moving around a lot more and you're taking up a whole lot more room. And that's the idea of thermal expansion. That's one of the ways that we know sea level is rising. So it's not just glaciers melting and adding water into the ocean, it's also how much energy is in those water molecules and are moving around. Or how much energy is in those carbon dioxide molecules in the atmosphere and is moving around. So what we're going to do with all of our students at one of our stations on our night of training is we're actually going to have some music down in Hot Pink Flamingos near the wetland birds and the rising sea level interpretation area, and we're going to play some music and have our students dance around too. Because one of the things about learning is, a couple weeks ago we talked about the auditory learners, the visual learners, and the kinesthetic learners. And those kinesthetic learners, this is one of the ways that they learn, is by really experiencing kind of the slow, calm, cool version versus the really energetic, excited, moving around version. So it's a way to get across the idea of thermal expansion in a really fun, exciting way. And then you go home and talk about it. You can talk about Sarah May's music selection versus Jelly's and Lady Gaga.
And
So-
you guys get to pick the music that
And
we
you guys
use
get
on
to pick the
January or
music.
June 20th.
Exactly. So last week we asked you all to think of some music options, and now you have an idea. So we need something kind of slow and also something kind of upbeat, but something that people would be entertained with. And I loved it that you guys were all like, "This sounds like Jelly's music," because it was. So does that make sense? Does anybody have any questions? Is there? Yeah, Pam.
Well, I'm just curious how many people, when they think of sea level rising, do they think of water getting bigger?
No. I do.
So how many of you, by doing that, get the concept of thermal expansion?
Yeah, Sierra said she's kind of confused about how the whole thing works. So in terms of thermal expansion?
In terms of how that relates to rising sea level.
Okay, so I'm gonna use Kim and Doug here to help me demonstrate. So if the water's nice and cool, if the music's really calm, we as a molecule are just kind of hanging out together. We don't have a lot of energy stored in us.
Is that CO2 or is that H2O?
This is H2O, so water. But then, as we get more energy in us, we start moving around more, and we start spreading out and taking up more space. So we're expanding the area that we cover. So we're using up a bigger space. So instead of water being close together when it's cool and doesn't have a lot of energy, when it's warm and has a lot more energy, it spreads out. And so that's got to go up.
Are they in like higher electron levels?
They are. Okay. Yeah.
So the connection with CO2, which I think was part of the confusion, it's CO2 that's focusing more energy into the oceans. The oceans are absorbing a lot of the excess heat trapped by CO2. And as you warm up all those molecules of water out there, each molecule takes up more space.
I get it.
And so the ocean gets bigger. And it's not adding more water, it's just making the water bigger.
Exactly.
So you were illustrating both were water molecules. One was moving slower, one was moving faster.
Exactly.
Okay, I thought at one
That
point.
was unclear?
Yeah.
Okay.
Yeah, the CO2 word was, get it out.
Yeah, I wouldn't use the CO2. Stick to water.
Water.
We talked about that today. What is the chemical equation when you got H2O and CO2 comes in with it? Is there a chemical change?
There is a chemical
CO2
change.
plus H2O equals?
Yes, there is. And we're not going to talk about that tonight.
Okay.
Yes, there is a chemical change, but it is kind of complicated, and we can talk about it one-on-one if anybody's interested, but we are choosing not to go that route as part of this training, just because not everybody's necessarily had that chemistry background, and so we're giving it to them in a really simplified model that hopefully they can understand.
It gets pretty crazy.
Does it?
And really, in terms of
Okay.
describing sea level rising, to be able to explain to a visitor thermal expansion doesn't involve that chemistry. We don't need that chemistry to talk about sea level rising and thermal expansion. So if you use the word thermal expansion with a camp kid or a teacher, even if the teacher is an elementary school teacher who is a language arts major in college, they're kind of like this about science half the time. And if you're talking to other TCL people or to visitors, if you use the words thermal expansion, it's going to go right over their head most of the time. But if you say, you know, when molecules get excited, they take up more space, and you can even talk about doing this dance. You can say, we did this thing to understand that, where we linked arms like an H2O molecule, hydrogen and 2 oxygen. You know what H2O is? Most people know that term. They know that that's water. And when we were dancing fast because we were warm, we took up more space, and that's what's happening in the ocean. You can use this to really explain it. And you'll have that muscle memory of what it was like.
So you don't need the chemistry stuff to understand thermal expansion.
Right.
But we are covering some chemistry associated with climate change.
Yes.
With the assumption that the kids are coming in as a normal freshman.
Yeah.
So
Yeah.
you will get pieces of it.
Right?
Yeah. Any other questions?